Welcome to Machine Learning at Home. So far we studied only one real method of machine learning, the linear discriminant analysis, which tries to combine initial variables in such a way that they will separate classes as much as possible. So this is the second method of machine learning today. This called CRET, classification and regression trees. This famous, interesting and valuable method of machine learning. So let us start from the loading one of packages. So again, this one is going with R, so it should be present by default. You do not need to install it. R part. So R part should be here. I hope it is the same result on all your computers. So now, as usual, for all machine learning stuff, we need again and again and again this training and testing data sets. So let us make them again. From same iris, we need to subset rows. So here, we'll do it with a sequence from 1 to the last row, with increment of 5, and iris test will be the same but reverse, so it will deselect these rows. Okay, done. So now we need to run a model very similar to LZA it goes. So we need to make our model, for example ISR. For simplicity, function to make a model called rpart, and then we'll do the same formula approach. Species, the last variable, against all other 4 variables, and data equal to iris dot train. Okay. So now we made a model. A model is interesting. So if we type it, we see how it works. So very unsimilar to what iris LZA outputs. So what is it in short? CART, or classification and regression trees, tries to separate the data set in multiple sequential steps. On the first step, it will look on a character which separates species, classes, the best, and apply it. So, for example, in our case, and that step is numbered as 2 and 3. So it found that petal lengths lesser than 2.6 will separate setosa in a very well good way. So like almost all numbers here are equal to 1, 0 or 0.5. This is important. So these are important to understand how good is our separation. So all setosas will go to that group petal lengths lesser than 2.6, and if petal length is more than 2.6, there will be everything else, versicolor and of course virginica, so they must be separated further. So R took the next step, numbered them 6 and 7, and on that 6, 7 step it is using as the same character petal lengths, but now it will use it in such a way that all irises with less than 495 in petal lengths will go to versicolor, and all 10 versicolor will go here without any problems. And if petal length is more or equal than 495, this will be all virginica. So nice clean separation. Again, it will split data into parts in multiple steps. Each step will contain just one binary 1 splitting, and then it will proceed to the next step, and so on. So this is a stepwise binary approach, unsimilar to linear discriminant analysis, which tries to use all characters simultaneously and make a linear combination of them. This is a different, somehow more similar to our median approach, if you remember that video. So now we can use the model and see how well it will work for our testing data. So let us make a new prediction object. So and use same function predict. I appreciate this simplicity. So we use the same model which we just created, iris.r, and then we use as a new data iris test without, of course, our species variable, which is number 5. Okay, so everything is done well, and we can use our pret it contains a list of numerical predictions for each classes, and to use it for the table we should repeat our analysis and make the type of prediction equal to class. So this is a difference from LDA, so you can specify type. Without type it will be only numbers. With type class it will be names of classes. That's what we need actually. And now it will be slightly different. It will contain names of classes. And finally we can use that iris.pred to create a misclassification table. So we use a original species data which was hidden from the analysis and our new predicted names of classes. So now results are quite impressive. Only 8 entries were predicted not so well. So 38 of versicolor were predicted well, but 2 went to Virginica. Virginica by itself has slightly worse results. 6 of them went to versicolor, whereas 34 stay in Virginica as they should. So this is our result from CRHC, CART method of analysis. This analysis also has multiple additional features. For example, we can think of probabilities of belonging to 1 or 2 or 3 classes in the same way as we did for linear discriminant analysis. In that case, we can repeat the predict function again, but now we'll calculate it with a type PROB, so probability. And now we'll look on that probability for some middle rows, like we did for linear discriminant analysis. So that's an interesting difference. Linear discriminant analysis had some decimal numbers here. However, in CART is only 0 to 1. CART is a binary method. It can only say yes or no. It cannot give any shades, cannot measure the uncertainty so well as it was in LDA. That's a bit of minus for CART, but a giant plus for CART is that it does not need only numerical characters. CART can be used for any kind of characters. It can use, for example, color. You can specify a variable which says red, yellow, blue color, and it will use it. So CART is almost universal method, whereas linear discriminant analysis prefer to data be linearly separable and, of course, measurement. So that must be numbers in LDA. So cart is much more universal. This is why it became so popular. Minus, of course, it's very binary, black and white method. Also, people say that easy to overfit, especially for the large data. Cart might be too detailed method. So if a training data set is big and complicated, you can overtrain cart and then it will not work well for the test method. So there are other techniques which allow, for example, to trim the cart model and make it more more available for some tasting data. So there are pluses, universality, and minuses. It's prone to overfitting and it's kind of black and white. So each machine learning method has its pluses and minuses. That's why people use all of them. Okay, and now my assignment. So we know now how to make LDA, linear discriminant analysis, and cart with function rpart. So let us compare which is better. So use the same set of test and train data and apply to them LDA and then rpart and see which of them performed better. I think that might be easily done. Thank you.